Okay, hey, page 103 that's due today. At some point, that was one that you got last Thursday, I think, when I was not here. To make sure those are at some point are getting turned in. Grades will be updated today. Actually, I'm going to try to enter grades as you guys are working today. It's pretty straightforward. We're going to go over the next part of the section that we're in. We're in section 1.3, which is not really crazy new stuff, so that's kind of nice. We're reviewing something that we've already discussed, which is conditional statements, but we're going to talk about a few topics underneath them, a couple vocab terms today. And then what I assigned today will be due later this week. We'll be due, I think, Friday this week. So that'll be one of your last assignments this week, so it'll be kind of nice. So other than that, we're going to be just kind of moving on and talking about other topics this week. So yeah, it's pretty straightforward. So alrighty. So let's go through a couple notes here. Let's see. Hey. All right. You can tell us. Thank you very much. And at some point, I do have a new scene chart. I'll show you later today. I forgot all about it yesterday. So we were in pause yesterday. All right. So we're on section 2.3 today, conditional statements. This is kind of our main goal. We've already talked about a conditional statement. What do you remember about this term? What are conditional statements? How do they look? If-then statements. Yeah. So conditional statements have an if-then in them. Perfect. Okay, so it's an if-then statement, right? So the example I think I've previously used is if I'm listening to music, then I'm using an iPod. That was the example, right? It's an if-then. We can use this for math, right? A lot of people do this. When they're doing an if-then statement, they'll write it like this. Right? So if I ever, I've seen this before when I've taught algebra and pre-algebra and 6th grade math, 7th grade math, and all that. You give a problem like that, x plus 8 equals 10. It's on a worksheet or it's on a book assignment. And all you'll have is somebody just writes x equals 2. That's it. Now, don't get me wrong. That's the correct answer. But the problem is, they didn't show any work. Like, no process. Like, the whole point was to show, okay, how did you get to, right? So the process was to, like, subtract 8 from both sides, and you actually write that down. And then you write to them that your answer is 2 in the very end, right? But I always get the same excuse. Well, I can do it in my head. I don't know the steps. I just know the answer. Well, there's some process there. So this is where most people would probably explain it. They would use this as their reasoning why the answer is 2. It's just that's the way it is. It's the answer. Well, you have to show work. So there is stuff behind a conditional statement. So this is just something that I normally see. Again. There is a hypothesis, there is a conclusion. Now, on that sentence, which one's the hypothesis? Say it again? Which one's the hypothesis?
If.
Yeah, this part. It's not even the word if, it's x plus 8 equals 10. That's the hypothesis. So, what you're going to have today is, or maybe tomorrow, I don't know if we'll get to it today, I think we will. They're going to give you a sentence like this. Very easy sentence, just it's written out. And what you're going to have to do is identify which part's the hypothesis. So what I would do is I do that. I underline it, put a little h next to it, or or circle it, put an H. Right? That's what I would do. The conclusion is this part. That's the conclusion. The hard part about a conditional statement is that there's a bunch of different ways you can write it, and that's what throws people off. Okay? So that the different forms you can have the if-then part, right? They could write it like this. It's the same sentence. X equals 2 if x plus 8 is equal to 10. Which one's the hypothesis? Yeah, it's the part that follows the word if. Even though they wrote it differently. Now, the only difference is if they use this. There's the main difference. There's where some people will mess up. They'll look and go, oh, it says only if. So the if part is the x plus 2, or x equals 2, that's the hypothesis. That's the only sentence where it's different. I know it has the word if, but they said the word only. Only if. That means that's the conclusion. The conclusion is only if x is equal to 2. So that's the difference in you don't have to always write if-then statements. You could actually write it in different formats. All right, any questions with a conditional statement to begin with? We're going to look at more of these, like more math-related types. Okay? But I did want to show you that there was different ways to write it, other than always just writing if-then. So, all right, so I'm going to use this as my example today. Okay, the other terms we need to talk about is counterexamples. So counterexamples, if you don't know, they're basically used if you know that the original statement could potentially be false. If this statement here is false, then you would come up with a counterexample. Now, how counterexamples work, if it's possible, right? The first part, the hypothesis here, has to be true. You have to assume that's correct. The conclusion is wrong, if it's wrong, I should say. So, now, on this sentence, is that true or false? It's true. So we, in this particular case, this particular sentence, we would not have a counterexample. There wouldn't be one. Okay, but let me give you a math statement where you could potentially find a counterexample. So here's your sentence here. It's an if-then statement. It potentially has a counterexample to it. So here's the sentence. If a quadrilateral has 4 right angles, then it has to be a square. Okay, so think of this object. Think of a quad. How many walls does a quad have? 4. So the 4-sided figure has 4 right angles. What's a right angle? 90 degrees. So it has 4 walls and it has 90-degree angles at each of the corners. Does it have to be a square? Why? It has to have equal size. Did I say anything about the walls being equal? So what would that shape be? Rectangle. Rectangle is your counterexample. Rectangle has 4 right angles. It is a quad. So it does meet the hypothesis, but the conclusion is false. It didn't have to be a square. It could have been a rectangle. That's a counterexample. It's the same picture. 4 walls, 4 right angles. That's the definition of a rectangle. It didn't have to be a square. A square is a specific type of rectangle. That's what you need to realize. So that's a counterexample. The hypothesis has to be true. Has to be. All right. Now, the other words we're going to talk about today. Converse. Converse is taking this sentence and flipping it. The original sentence. So, let me write that sentence as a converse, the one with the quad. If if a quad or lateral is a square, then it has 4 right angles. So, how Converse works, you flip the sentence around. So you put their conclusion as the front. So the front now is I'm going to put the square in the beginning. So if your quad is a square, then it has the 4 right angles. So you're flipping the hypothesis conclusion around. Now, this is a new sentence, agreed? So, is that true or false? If it's false, is there a counterexample to it? So, quad is a square, and it has 4 right angles. True or false? That's a true statement. Isn't that weird? Like, the original sentence, we found out that could be false. Don't get me wrong. It could be a square, but it could be a rectangle, right? There was a likelihood it was false. This sentence is true. When you do a converse, it's a brand new sentence. The truth value of it does not have any bearing to the original sentence. They're completely independent of each other. You could have a false true or a true false situation or a true true situation. So that's the idea. They could both be false. But I want you to realize that converse is where you just switch the sentence around. On the original one, on that first one, how would I write that as a converse, that original sentence? Let me say it out loud. Yeah, if x is equal to 2, then x plus a is equal to 10. That's the converse. That's also a true statement. It's true. That's just how they work. All right. Any questions with the word converse here? Now, the other terms we're going to discuss, because we'll come back to this here in a little bit. The other terms we are going to look at, we're going to look at an inverse. That's one of our words we're going to look at today. In fact, I'll give you the formal definition for a minute. We're going to talk about a contrapositive today. We'll give you that formal definition. They're based on these original items and the original conditional statement. So we'll come back to these in a minute. Then, if we have time today, I do want to talk about negating. Because negating actually goes with these two. That's where this inverse and contrapositive come into play. So we talk about negation of these. Okay. Questions or comments on the new words we're going to discuss today? Especially these two. I don't think we've ever discussed these yet. Right? Okay. All right, so let's go through these. The next couple slides might go over these words one more time, just to give you like a formal definition. But I do want to get to these words. These words I want to finish with today. And eventually, I don't know if we'll get this today. We might look at this one tomorrow. The biconditional. Biconditional is a certain case where conditional statements meet a very specific certain standard to it. So we'll look at a biconditional maybe tomorrow. All right, but that's kind of our goal today is go through these two for sure. And I want to give you the formal definitions. Okay, so let me get rid of these slides so we can go through some definitions here, and I'll put some examples back on the board. All right, so what we're going to be talking about is this idea of related conditions. Related conditionals are there's some type of relationship between the original sentence and then how you modify it, like how you do a converse or an inverse or a contrapositive. So all these sentences are somehow related to each other. That's why they call them related conditionals. There's different ways you can write the sentence down. It could be true or false. That has nothing to do with it. It's just the related conditions. So the first one we talked about was the converse, right? We just did that a little bit ago. It's when you formally exchange the hypothesis conclusion of that original sentence. That's what we just did a little bit ago, right? We took that sentence with the quad has 4 angles, and then it's a square. We flip the sentence around. If it's a quad is a square, then it has 4 angles. So that's a converse, right? That was the example we just did a little bit ago. Okay, is there any questions with that example? Okay, that one's easy. I know we've discussed converses before, how you can flip sentences around. It's a brand new sentence, so it's true or false. So you have to go back there and look at its truth value. Now, the second word that I want to discuss was inverse. That's the new word. So let's talk about that one. The inverse is when you negate the hypothesis and conclusion of the original sentence, the original conditional. not the converse. Okay, so let me give you that original sentence I had on the board. So this is going to be my example. Okay, so if x plus 8 is equal to 10, then x is equal to 2. Okay, so this is the original conditional. What an inverse is I negate both of them. So I put literally the word not. If x plus 8 does not equal 10, then x does not equal 2. This is the inverse. Does that make sense? Negating. Now, is that a true statement? Yeah. I mean, if x plus 8 does not equal 10, that means you do not have 2. If it was equal to 10, x would be 2. 2 plus 8 is 10. So since we're not equal to 10, x is not 2. What you're looking at there is you're looking at the idea of domain. You're going reversed, right? You're negating things to figure out what you can't possibly use. You will not be using 2 in that problem. Okay, so that's an inverse. Most people think it's pretty easy. The hardest part is remembering that. You're negating the original sentence, not flipping things around like a converse would. Now, the reason why I gave you converse earlier is because the next word is going to use this idea of negating, or you put the word not in there, but it's using it for the converse. So the next term, I'm going to use the same sentence here. Okay, the next term is a contrapositive. That was the one I had in that first slide. Okay, contrapositive is formed by negating both the hypothesis and conclusion again, and negate the both, but of the converse of the sentence. The converse of it. So this is going to be my example again. So this is the original conditional, right? So the first thing we need to do is we need to write the converse. So what is the converse for this sentence? You said it earlier. What was it? Okay, so this is the converse. Okay. But what we're going to do is we're going to do the contrapositive to it. We're going to negate this thing. We're going to negate the converse. So this is the contrapositive. So, if x is not equal to, then x plus 8 is not equal to 10. Is that a true or false statement? If x is not equal to 2, then x plus 8 cannot equal 10. That's true. And if you can't use the number 2, then there's no way you can add it to 8 to make 10. That's the idea. That's a contrapositive. Okay, are we good with those simple sentences? Now, the reason I bring these up, the book doesn't talk about these too much. They're just vocab words. They use them every once in a while. The problem that I have is that, like, especially for me, when I was in school, right? I remember talking about, conditional statements. I remember talking about Converse, and then I went to college, and I took a, college-level geometry class. These words come up a lot. And at first, I had no idea what they were. Because my high school math teacher never talked about it. I had no idea that you had to do the converse and then negate both of them. I had no idea. So that's why I'm giving you to now. You need those formal definitions. The book hints at them, but it never really asks you to work with them ever. It just has you work with your original statements or the converses, but never negating stuff. So I just thought this was interesting enough that we need to discuss it, because this is something you will see if you especially go into math at some point. Okay, questions, comments, concerns on any of the 3 words? Okay, now, next thing I want to discuss is, again, related conditions. So, we're relating the original sentence down. But I want to talk about logical equivalence. This is a word that the book uses every once in a while, and when I was kind of reading through the chapters and stuff. Basically, the best way I can explain it is when you write a sentence, a conditional statement, differently, like you write it in the different forms. You write it as a converse, you write it as an inverse, you write it as a contrapositive, and they're all true. Like, somehow the sentences are working out every single time, like that last sentence I gave you. Those are called logical equivalents. that things can be equal, like the truth values are all the same, it's still the same sentence even though you wrote it differently. Those are logical equivalents. Now there are certain stipulations to have a logical equivalent, like how you can label it as this. Okay, so number one, the statements have the same truth values, no matter how you rewrite them. So that was the little hint I gave you. But also, this is the other stipulation. The original conditional statement and its contrapositive are equal to each other. That's how you know it's a logical equivalent. So what that means is, you know that original sentence I gave you, that is x plus 8 is equal to 10, and then x is equal to 2. Then we did the contrapositive just a little bit ago where you do the converse and you negate both of them. If both of those are true for some reason, then you know that your sentence is automatically a logical equivalent. That means the converse will also work. So it's just like this weird little like check you can do. Well, to me that's a little silly because if you want to know if the converse is true, just write the converse and then check if it's true or false. Why would you need to go through all that work writing the converse, then negating it and then saying if that's true or false? So I thought this was a little weird. This is a little weird test that they show you in your book. There's also another test. The other test is you write the converse of the original sentence. So like if x is equal to 2, then x plus 8 is equal to 10. And you check the inverse of the original condition. The original condition. The inverse of the original part. So you negate both the original sentence. If both of those are true, then you have this idea of a logical equivalent, that the sentences are equal no matter how you write them. So that was the sentence I just gave you. That was a logical equivalent. X plus 8 is equal to 10, then x equal to 2. The reason why all the sentences, why the converse works, why the inverse works, why the contrapositive works, is because this sentence, if x plus 8 is equal to 10, then x is equal to 2. The reason why this whole thing works is because it's literally a property in mathematics. It actually has a name. The reason why these actually work is because it's called the addition property of equality. That to get from this sentence to this sentence, you literally just add 8 to both sides. That's literally the additive property of equality. That when you have an equation, you can magically add numbers to both sides and the equation still balance. So like somebody, give me a random number. Steady. 5? Okay. Would you agree that 5 is equal to 5? Okay, so that's an equation, right? It's got an equal sign. We have two things. Give me any other random number you can think of. 7. Okay, that's a weird visible system. All right. Would you agree that if I magically added 7 to both sides, that the numbers are still going to be balanced? Yeah, because it's a property in math. I can subtract both 7s from both sides. I get -2s. They're still equal. I can multiply by 7. Get 35 and they still equal. I can divide by 7s and they would still work. It would be a decimal, but it would still be equal because those are properties of equality. That's how you know you have a logical equivalent, is when it doesn't matter how you reorganize the sentences, how you compare the contrapositive and conditional, you compare the inverse and the converse. You know that they're going to be logical if it's literally a property in math. Property in mathematics, and there's not some weird stipulation on it. Okay, so that's just something to think about. And I saw this in your book, and I thought it was kind of goofy. I understand where they're going with it, like how you can check whether things are true or false. There's another word for this, other than logical equivalence. When sentences, no matter how you rewrite them, that they're equal, they're actually called biconditional. That was that term I gave you earlier. When no matter how you rearrange the sentence, it's still true no matter what. That's what makes it a biconditional, and that's this idea of logical equivalence. So they've used this term differently in other textbooks, and that's where that other term comes from. Okay, questions, comments, concerns? I need the examples I give you. Okay, so this is your homework I'm going to give you. It's due on Friday this week. Now, you're looking at it going, oh my God, this is getting weird. This is getting excessive. We're getting a ton of homework. This is really easy. We're giving you a sentence. You have to identify which one's the hypothesis, conclusion. So you just literally rewrite the sentence, underline, put H and C. There's a couple sentences like 10 through 17. They're going to ask you, is this true or false? So if it's true, just write true and move on. If it's false, give me the counterexample, like that idea with the square, right? That you had a 4-sided figure with 4 angles, but then I said it had to be squared within a rectangle. That's something you have to think about. Let me give you one example here of a tough problem. This is a mathematical statement, right? The weird part is that sentence is true. That when you x plus 3 is greater than 1 if x is greater than negative 1. Okay? That's a true statement. If I were to plug numbers that are greater than negative 1, somebody give me a number that's greater than negative 1. 7. Okay. So what's 7? All right, 7 plus 3. Would you agree that's greater than 1? This is weird, right? It's still a true statement. The problem is that sentence, that one in green there, that conditional statement, has a counterexample to it. Yeah. Say it? Yeah. X is greater than negative 2. It still works. They're trying to limit you to the only numbers greater than negative 1. When you knew that there was a couple numbers that you could have picked that were greater than negative 2 would have worked. It wasn't the only numbers that would work. Because I can pick any number greater than this. And how I know that is you just solve the original problem. You know, you move 3 to the other side and you subtract it. So if I subtract it to the other side, that's negative 2. So, sure, numbers that are greater than negative 1 work, but they want the only numbers. You're skipping all the decimals above negative 2, like negative 1.5, negative 1.7, negative 1.1, and so on and so forth. Any numbers greater than that. Does that make sense? Like that's a counterexample? Even though the original sentence was true, it's not the limit to it. And another type of example that I always think of that always gets people, because they're always like, well, it's true. It's this sentence. This sentence. If x squared is equal to 4, then x equal to 2. There's a counterexample to that problem, even though it's true. It's a true statement, right? X. If you were to use 2, right? 2 squared is 4, correct? 2 squared is 2 times 2, that's 4. But there's a counterexample to it, even though it's true. What's another number that I could use instead of 2? Think about that. What number could I plug in here? I'm giving 4 out. Yeah, negative 2. Negative 2 works. Negative 2 squared. Well, that means you're taking negative 2 times negative 2, and the negative cancel, and you're left with 4. So that's a counterexample, because they're saying that this is the only number that works. That's what they're literally saying. It's the only number. X has to be 2. But then negative 2. That's why it's a counterexample. Alright. Does that make sense now? Like, even though this statement is true, you have to think kind of outside the box a little bit. Is there another possibility that could work here? Are they limiting you? Is there more than just those answers? So sometimes you just have to solve it. You have to think outside the box a little bit. So that's what your 10 through 17 is. It's very true or false. And if you can think of other counterexamples, then you have to list those. Okay. All right. You're free to work. If you have not turned in page 103 yet, get that turned in. As you guys are working, I'm going to enter some grades for you guys so that you guys can see your updated stuff. And if you're missing anything, I'll let you know. Remember, late homework or whatnot, turn in before the end of the week, like by Friday. If you have anything that's late, you want to redo, whatnot. for like the next couple weeks, which is awesome. If you have cheese, then you have cheese. Oh. Cheese, and then there's calcium. Okay. Actually, there's like 6 of them. Hello? Where'd she go? I noticed that you. So you go. All right. Locked out.
Oh my gosh. Or do you want to see my bruise running into the table?
Oh yeah, when you flipped it.
Look at that. Yeah.
You didn't break anything, did you?
Nope.
Okay.
Hurt though.
Oh, I
It was
bet.
sore.
I heard you flipped it pretty hard.
Yeah.
I still need to watch that game film. That was
I want to
the
see it too.
that was the Central Springs game.
Yep.
All right.
For sure. Oh, man.
I'll pull it up and I'm gonna take a look at it. At what point did that happen? Was it right in the beginning of it?
I don't know. Yeah, I think it was in the beginning.
You gonna put it up on the screen?
Yeah, you should put it up on the screen so everyone can see. Yeah, you guys can see me run into a table. Look at my bruises from running into the table.
Oh my gosh. Oh,
Yep. Oh gosh.
It's running on the other side, right? Or is it on this side?
It's the other side.
Table's over here, right? Oh yeah, so we gotta be on the other side of the net. So we
Other
gotta
side.
be
So
in
is
game
it
two.
like the second game maybe? I think it was.
How do you run to the table? We're trying to see the ball.
Yeah. And I flipped the table over and all the papers flew. It was embarrassing.
I'm just looking at the table and seeing when that table suddenly like looks like it's moving. I go
We'll have to watch tomorrow.
we go to the same town.
I just searched cities named Charlotte, and then it pops up.
I just typed in Charlotte and it just kept giving me North Carolina. So Google only considers